Again, what I'm trying to do, I'm trying to get R out of here, right? How do I break it? Well, what I need is not Q. That's how this would input, right? I need not Q so I can infer R. I see not Q right here. Great. Okay. But not Q is embedded in if P, then not Q. So I can't just immediately break that expression. I can't just pull not Q out. So I have to do something else. In this, you just saw, we have something, conditional elimination. We'll call C E, although I need to give it a different name, right? Because I'll call it CEL. This conjunction elimination is already CE. And what this does, it allows us to say if P, then Q, or if phi, then chi, and you have phi, then you can infer chi. And this would be an instance here. If I could have, if P, then not Q, I'm sorry, if I have P, if P, then not Q, and I also have P, then I can infer not Q. Cool, because that's what I'm looking for. If I have, so what I want to do then is I want to combine if P, then not Q, and P, allow me to infer not Q. Then I want to infer or apply not Q to if Q or R, and that will allow me to infer R. So if I spell that out using our proof rules or instances of them, then what I should have, something that looks a little like this. So I have line 5. I'm going to add to this. I'm going to apply if P, then not Q, and P together. And I'm going to do that, and it's going to allow me to infer not Q. And how do I justify this? I'm not going to write that all out, right? It's already kind of justified by the truth tables. I'm just going to abbreviate. I'm going to put CEL for conditional elimination. You can also put Modus Ponens if you want. Modus Ponens, again, the Latin. But this helps me, this is a justification. Now I also need to put in the number of lines that I'm referring to, and that's line 1 and line 3. Now, you need both. You need both the abbreviation of the rule and you need the lines. The lines are the input. And so for conditional elimination, you know you need 2 premises to get the conclusion. So you're going to need to cite 2 lines. Not all of the rules are like that. Conjunction elimination, P and Q, you can infer P. You just need 1 line to input and you get 1 line out. So keep that in mind. You're going to need to cite these things because I'm going to need to see that you know that you're applying the rules appropriately. So in this case, 1 and 3, conditional elimination. That lets me get not Q. I'm not done because I'm trying to get to R, right? So what do I do now? Well, I have not Q. You can effectively think of this as input that you can use now because you've inferred it. So I know I need to connect not Q and Q or R. And I need to use disjunction elimination. And when I do that, that allows me to infer R. Now, I've cited here line 2, but also line 5. And I've used disjunction elimination. Because I know if I have not Q and Q or R, then R follows by disjunction elimination. And that is it. I'm done. What I do now, because again, I just like a bit of flourish, is I box this and I mark out the show line. It will actually become important that you have a way of documenting what you've proven because we're going to prove things inside other things. So it's good to kind of keep a legend where you can box up and say, this is isolated off. I've already proven this. What I really am interested in is that. And so effectively what this means is that you have shown using direct derivation methods, like direct proof rules, that R follows from these. And we want to cite that proof, that like proof method strategy. And so we had justification for marking off the show line as well. And it's just this, D, direct derivation. And this just means you've used only the rules, like those direct, one of those 7 rules or multiple combinations of those 7 rules that we just discussed to get R out of the premises. And that, in a nutshell, is how we roll. Like, this is the proof theory for the direct derivation method for L1. Now, let me show you one more. And incidentally, I'll say, go if you want practice, and I'm sure you do. One of the reasons I picked the Hardegree textbook is because it is full of examples and solutions of proofs. It is just probably the best, like most exhaustive textbook I've ever seen, with full of proofs and solutions, which is why I use it. I want you to get as much practice as you want, and there's plenty of examples, simple, complicated, and most importantly, plenty of answers, and so that you can check your work and you don't have to guess. And so let me walk through another example. And so I want to say, I'm going to put in not P and R, and I want to say, let's see, I want you to be able to derive, let's see, Q, not P. I want you to show not P. I want you to think about this one for a second. So I have written not P and R, first premise. If Q, then not P, second premise. And I just want you to show not P. How do you do it? It's a direct derivation. I'm going to try to trick you sometimes. Can you even see that? Try to trick you sometimes. How can I possibly fight off the glare? This is absurd. You guys with me? P and Q. Maybe I'll just write it low. Gosh. All right, I'm gonna do that again so you can actually see it. Not P and R. Jeez. 2. Q. If Q, then not P. I want you to show not P. So prove that. Hopefully with all my shenanigans here, you had plenty of time to actually think about it. I'm going to try to trick you sometimes. This is one of those times. You might be thinking, oh, I'm going to apply all these rules. I'm going to get real complicated. Just try to keep in mind what the rules you have at your disposal are, and, you know, make your life easier if you can. So you want to show not P. You've got not P. You've got not P. Remember, we know how to add on negations. You don't have enough negations in these P's, right? There is there's negation, introduction, in E, or in I. That allows you to say if you have phi, then you can infer not phi. Basically, again, introduce the negations in pairs. Also, we have, in this case, it'll be useful, conjunction, elimination, CIE. And this allows you to say if you have phi and chi, you can infer phi or you can infer chi. And these are the kind of actual rule-based versions. The kind of everything is an instance of these, or the rules are like what we're playing with here in the proof calculus, instances of these rules. There's, like, properly speaking, the rule form. And you can kind of walk backwards. So you need to show not P. You have not P over here. That's not going to help you. You're not going to be able to generate an odd number of negations from not P. But you do have this not P, and you can generate not P from that if you could apply negation introduction. Of course, this is embedded in a conjunction, so you need to break that apart. So line 4 should be you breaking that apart. And it's just, you shouldn't be able to infer not P, and you'll cite line 1, negation, conjunction, elimination. And no, remember, you needed to cite one line because you just had one premise in this rule. Now line 5, because we want to get to not P, you just need one line to introduce this, or to use this rule, not P, and that's line 4, negation, introduction. That is it. That's what you intended to show. And you did it. Let me remove some of this fluff over here. You did it with direct derivation. Easy, easy. Hope. They get a little more complicated than that, but for the most part, this is it. Like for the direct derivation style, this is it in a nutshell. You just look at the premises, look at the conclusions, see what you can apply to start breaking things out from the premises so that you can find a way to get to the conclusion. If you can do that by just applying one or more of those 7 rules, it's a direct derivation. And you just kind of, it's almost mechanical, right? Like, can I use this rule there? Can I use that rule there? And your clue is what's the main connector? What's the connective binding these things together? And that's it. Now, next time we're going to discuss the conditional introduction as well as indirect proof methods. So we're going to kind of build on our direct derivation style. We're going to keep using these rules so you get plenty of practice, but we'll also have like different methods for introducing new information or deriving what can sometimes look like rather surprising conclusions from connection or combinations of premises. So for that, next video.